All right. So let's open up the source file. This is nim, and this is our nim test. Luis brought up a good point. He didn't know he did, but you did. You brought up a good point when you emailed me earlier this week, because you're like, I'm passing 3 of the 4 tests. Like, how do I know what I'm supposed to be doing, or how I'm supposed to pass it, or what you're looking for? And so there comes a point that you guys need to kind of understand what's happening in these test files. You don't need to understand it perfectly, but you guys are starting to get a little bit more knowledge under your belts reading code. So this should start to make sense to you. So I first want to walk you through this test file so you kind of know what you're looking for. The first thing is I'm declaring the functions. These are just the functions that I'm going to be calling. These are the functions you guys made in that other file. This right here, this check test, is always going to be in every test file. It's just a little function I made, and the parameters I pass in are the test number, how many you've gotten correct, what the answer should be, and what it is. You don't need to worry about this template yet. We're not learning this till the end of the semester. So don't worry about that quite yet. But basically, if you get it right, I'm adding it to the correct test variable, and I'm saying you pass the test. And I'm returning true. Otherwise, I'm saying you failed. This is what you gave. This is what you should have given. Okay, so it kind of gives you an idea of the answer you gave versus the answer you're supposed to give, and then it returns false. Everything after that, this is going to vary project to project, but it's going to look similar to this. And what it's going to be is I'm going to have the captured output, I'm going to have the expected output, and then I'm going to call my check test. And so if you did it right, check test 1 is going to be correct, and it's going to be test passed. If it's wrong, it's going to fail and tell you why it failed. So sorry to put you on the spot, Luis, but in Luis's example, I don't remember quite what it was, but he was saying, hey, this one test is failing. So what I did is I looked at it, and it was like test 3, I think, or 2 or 3. So I looked at it, and I was like, okay, test 2 is failing. What am I doing in test 2? Well, in test 2, I'm calling the isValidMove function. So I knew to go to the isValidMove function and see and look there and see where the issue could be. So if this happens to you guys in the future, see what test number it is, and then look for these functions, and the first parameter is the test number. So you're like, test 4 is failing, and you can see like, okay, what's the captured output? What is it calling? You can kind of get an idea of where to look. Also look at the expected output, because a lot of times for the expected output, I hard code something. So in your previous assignments, when it was like, take the area of a square, I just hard coded parameters, and then if your function worked, it would have given me a specific output. So things like that. Does that make sense? You guys don't need to get lost in this other stuff. Hey, look, you know what this is though? String stream. So what I'm doing is I'm getting the input, and I'm saving that user input in a string stream, kind of as a variable, so I can call that. So you can start to recognize these little things as we go along. But okay, to the actual assignment. So the first thing is create a function named isValidMove. It needs to have a Boolean return type, and it needs to take 2 parameters, int userMove and int stones. This function is to determine if the move is valid or not. If the user move is less than 1, greater than 3, or if the move is greater than the number of available stones, then return false. Okay? So in plain English, what would an invalid move look like? Yeah. More than 3, or
less than 1.
Or there's one more.
Anything that's not a number.
Okay, or that's actually true. If it's more than the number of stones that are in the pile, because if you only have 2 stones in the pile, you can't take 3, right? Even though that would otherwise be valid. So that's what you're right. That's good. So the return type is Boolean. So how do I declare a Boolean return type? B-O-O-L, and it's called isValidMove. And what are the parameters? Stones. Okay, so pretty much all the logic is to return, because Booleans return either true or false, right? True if it's valid, false if it's not. So how do we declare if a move is not valid? What's up?
Cool, and I call mine valid move, and set it to false.
Oh, I like this approach. This is different than what I have. I wanna see this through. Okay, you said equal to false, and then what?
And then I did an if statement.
Oh, okay.
And then it's not.
Like the bang operator.
Bang operator.
Yeah.
And then open parent.
Parentheses.
Yeah.
Okay.
And then user move less than one,
User move less than 1.
or,
Outside the parentheses.
no, inside.
Inside still.
Yep.
Okay. Or.
User move greater than 3,
Oh my gosh, I can't spell. Greater than 3.
or
Okay.
user move greater than stone.
Greater than stones.
Right, and then inside of that, brackets.
Like that.
Yep. Valid move equals true.
Why is it
Outside of the if statement. One more answer, there you go. Return valid move.
Okay, what's up, Luis?
I was just curious why you weren't putting in is valid move.
Oh yeah,
Why you're putting in valid move instead of
yeah.
do is valid move.
Yeah, it is valid move as the function, and valid move is just the variable. Yeah, that's really solid. Does anyone want to walk through what's happening here? What's line 12 doing?
Creating variable.
Of type Boolean, and it's automatically setting it to false. Okay, this is kind of fancier logic. How does this parameter work?
It's checking to see if the user move is within the requirements.
Yeah.
If it's less than stones, if it's less than 3, more than 1, and if it is, then it must make valid move true.
Okay, so this part is confusing me. Wink, wink. If it's less than 1, it's not valid, right? If it's greater than 3, it's not valid. If it's greater than stones, it's not valid. So why is he putting valid move equals to true down here?
Because I put the bang operator.
Which represents what? Not, right? Very good, guys. Good job. Yeah, this is solid. Yeah, that's perfect. I love it. Any questions on it? Okay. So the next one is create a function named getUserMove. It needs to have an int return type, and it takes one parameter, int stone. The purpose of the function is to get the user moves. You will need to do the following steps. So we need to create a loop that will only break when a valid move is made. Inside the loop, ask the user how many stones they would like to take, and then have them input their answer. If the move is valid, return the user's move, else print invalid amount. Okay. So what's the name of the function? And I do it like this, right? This is how it works?
Int before
Oh,
get
oh, okay. And then we're good?
New parentheses.
Oh, okay. Okay, what's in the parameters? No, I don't know. Okay, int stones, right? Okay. So this one is like a gargly, like word salad of the steps to take here. So let's break it down step by step. First thing to think about, what is the purpose of this function? What are we trying to accomplish with this? The name doesn't give it away.
asking the user how many stones.
Yeah, this is the user taking their turn, right? This would be like you taking your turn. And so step 1 says create a loop that will only break when a valid move is made. So how do we do that? Probably a bunch of ways we could do it, but inversely, if the user doesn't know how to play the game and they just keep doing invalid moves, instead of breaking out of the function, it'll just keep telling you like, hey, invalid, try again, invalid, try again. So we've done this a few times now. How could we do this with a loop? This is how I would do it. Like I said, there's lots of ways you could, but what did you do? What did you put in the as the parameter?
Making true.
Okay, you did it just like that. Okay. Do you know what's funny about this? I promise you, I'm not trying to take credit. I'm just looking at, because I made this like 6 months ago. I noticed that I put the standard name scope resolutor for everything. I really do think that I was like, I'm going to do it different this time and see if they can catch on. I don't know what Past Pierce has done. Okay. How many will you take? So some of you ran into this problem. Why all of a sudden am I putting this STD before the C out? Who ran into this issue? Anyone else catch that there's no using namespace up here? You guys got that? So did you guys add the using namespace, or did you just add the scope resolutor?
I did the latter.
You added the STD before everything?
I'm trying to do that in the 2130
Yeah,
too. Just
better habit.
because from what I've heard, it seems better.
Yep.
practice.
Yeah, you'll start to see that when we start overloading operators. You'll start to see why that's important. Good.
That just makes things more clear.
Yeah, absolutely. Absolutely. Okay, so CN user move. So who wants to explain what's happening here? Should be pretty simple. Wait, what?
You need to create a
Verifying user.
You need to define user move
Where should I put it?
before
Any
the
place
while
before
loop.
choose.
What'd you say, Michael?
What did I say?
Yeah, I thought you said something.
I said any place before choose.
There you go. Okay, so now the user's going to put in their move. They're going to put hopefully a 1, 2, or 3. Let's say it's valid. Let's say they put in a 1, 2, or 3. How can we check that? Should we do something like that? If user move is greater than 1 and
You already have a function.
okay, so how do I do that?
Call your function.
See, you guys don't want to give me the answer, but you sure do want to correct me, I've noticed. All I got to do is say a really stupid answer, and you guys will be quick to answer. No, you guys are absolutely right. So user move and stones. This is the beauty of functions. We've already done this logic up here. If we could do this. I mean, that's fine. But what's the point? We're now repeating steps. So let's utilize the functions that we have, right? Okay. So what do I do if it is valid? User move. And this return works because it's of type integer. So I'm returning the integer. I'm returning the move. Okay, else. You guys are smart. You don't need me to drag my feet anymore. Invalid amount. Whoa, that was cool. Something like that, right? Okay, did I miss anything on this function?
No, but there's a good practice versus bad practice.
And I did the good practice, right?
No, you didn't.
Have a return again, just in case it falls out.
No, you do a break, and then you only have one return. So if you have returns in your code in multiple places, you don't know really what's going on.
So do I do the break here?
No,
Where do I do it?
where you have your return,
Break right here?
no, get rid of your return.
And I put my return at the bottom, right?
Yeah.
Does that make sense what Michael's saying? So it's good practice to always have only one return statement and to have that return statement at the bottom. If you have multiple return statements, it could get kind of hairy because you could accidentally be going into multiple conditions, or you could maybe when you're debugging, you don't know what return it actually hit. So what's better than what's put in the return here, you put break here, which always throws you to the bottom where you can return it. That makes sense, guys? Okay. Good job, Michael. Thank you. Okay. So now we're going to do the next one, and it's going to be called computer move. What's the return type on computer move? Int computer move. Oh. Int stones. Okay, so Michael,
Yes, sir.
walk me through this function.
Okay, so do int return val, okay, that's what I call it,
Okay?
and then just a semicolon, you can make it 0, that's fine.
Okay.
And then I just switch, number of stones, or just the stones variable. And open, yeah, there you go, case 1, colon, and, next line, case 2,
What'd you say?
case 2,
Oh, okay.
the next one is return val equals 1,
Return val equals 1.
and break. Case 3, sorry.
Return val equal 2.
Break.
Okay.
And then case 4. Return val equals 3.
Val equal 3.
And then default. I'll break that, then default. And this is return val.
Okay.
Okay, equals a function called generate random numbers, so I created a function for it.
Oh, okay.
But
But I'll do it like this.
yeah, you can do that.
First, basically, you're doing a random number between
Yeah.
1 and 3. 1 and 3 being inclusive. And then we also need to do break. And then what I also like to do, so it doesn't look as
Yeah.
messy, is I do that. I do that. I do that. Cool.
At the end, return val.
Earn the return. That's beautiful. So someone other than Michael now explain to me what's happening here.
It'll determine what return val is based on the number of stones remaining.
Right. Yeah. So it's looking at the stones. How many are left? So this is when I said this program is easy mode. It's easy mode because of this logic right here. Basically, if there's 1 stone remaining, the computer's not going to do anything, which is kind of silly. If it's case 2, so if there's 2 stones remaining, they're only going to take 1 of them. If there's 3, they're only going to take 2 of them. If there's 4, they're going to take 3 of them. Otherwise, it's just going to be random between 1 and 3, right?
So just for clarity, case one falls to 2, and so if it's 1 or 2, return val is 1.
Oh yeah. That's correct.
And then if you look up in your comments, it says.
Yep.
number of stones is 1 or 2.
That is correct. Thank you. If you wanted to make this harder, you would probably try to maximize these, right? If it's 1, they would take 1. If it was 2, they would take 2. If it was 3, they'd take 3. Otherwise, maybe random. But okay, I want to incorporate what we learned today with specifically enumerators. I want to make an enumerator that instead of putting like 1, 2, 3, 4, I want to be able, I don't know, I don't care what we call it, but I want to be able to call it, give it some sort of name, and put that instead. So what I'm going to do is I'll just put it before the function here. But someone walk me through how would I make an enumerator?
What do you want to call it?
Whatever I want to call it. Whatever I want. Okay. And then what are we giving it in here? give it. This is really silly, but let's just do this. It's the principle, right? Okay, so 1, 2, 3, 4. What's the value of 1 gonna be?
0.
So how do we fix that?
1 equals 1.
And then do we need to assign these to anything?
No.
Beautiful, guys. Okay. So happy you guys listen. So can I do this now? I guess if you really wanted to, you could.
They have to be all caps.
No, I just do that. I couldn't even give you a good reason why. Maybe because it stands out more. But I always do all caps for enumerators just so it kind of pops. Because once again, it's all for us, right? It's for our eyes. So, but no, it does not need to be. Okay, good. Anything else on this one? Okay. Last function, check win. Oh, this one should be easy peasy. Jeremy, walk me through this entire function. How do you do this?
So I start by making it a bool,
Okay.
check when. And then we're going to have, what is it, stones in stone.
Okay.
Then, I guess the better practice way would to first be assign or make a variable.
Okay.
I don't know, just do win, int win, or
Like that.
make it bool.
Like that.
Yeah. And then I just did if else statement.
Okay. If.
If stones equals 0,
Okay.
then
Oh.
we make win equals true. Then else win equals false. And then do the return inside of that.
Cool. Sounds good to me. Does that make sense, everyone? Okay. Do you want to know one other way you could do it? I'm going to keep your logic here for a minute, and I'm just going to do this. So pretend there's nothing above this, just brand new. You could do return stones equals 0. So just a little bit of shorthand. You could actually do the comparison right here in the return statement. But this is beautiful. Okay. Should we give it a shot? Okay. I'm going to run the test first. 12 out of 12 passed, guys. I'm so happy. If you're on VS Code, once again, you can go here. You can run each one of these and see if it passes. I know, green, oh, so nice. And then just for fun times, I think I'm already in the build, so I'll just call it in. No. Oh. Say that again. Oh, jeez. I'm in build, and it's just called nim. So, build. What am I missing?
We haven't coded any of the main yet.
Oh, I haven't coded any of the main yet. You're right. You're right. Sorry, Michael. I didn't catch what you said at first.
You listen to him, that's something.
Just tune Michael out. Okay, so this is kind of the first time we are doing main logic. So this is kind of what drives the game. So notice, didn't plan it, but still good a learning experience. The code works. Each of those functions independently work, but we still don't have a game to play. We're not driving anything. So let's start with this. Sorry, I'm looking at Oh, this is a good one. It's good to make sure you have like a random code generator to like set your seed. So I'll do something like that. And then you need to set your stones. I actually think the game of Nim, wherever it comes from, I think it's actually supposed to be 100 stones. We'll start with that. See how we'll say stones in the pile. Stones. Cool, something like that. If I lose one of you, please raise your hand. I'm kind of rushing through it, but I think you guys understand it well enough. So notice that my functions that have return types, I'm assigning to variables, right? Because getUserMove is supposed to return the stones, the number of stones. So I can assign that to a variable. So if this is my main pile, I want to subtract that from whatever the user move was. So far, so good, guys?
I have a quick question.
Yeah, what's up?
It's just about the SRAM.
Yeah.
What does the static cast unsigned int do in the SRAM?
Yeah, so do you know what variable casting is? So Python does that for us implicitly, meaning, I don't know if you guys remember from week 1, I like declared a variable of int and I called it something, and then later I called it again, but I gave it like a string. What it did is it implicitly casted it to be a different data type. In C++, and honestly in most languages, when you cast something, you need to explicitly tell it. So static cast is a little function I'm calling. It's actually kind of it's a template, but beside the point. And what I'm doing is inside this angled brackets, I'm giving it what do I want to cast it to be. And I'm casting it to be an integer, essentially. Oh my, what did I do? So what I'm doing is I'm taking this time 0, and I'm casting it to be an integer. What is time originally? Is it like binary?
No, highlight over it, I think it's a,
Oh, does it tell me?
yeah, it's a time piece structure.
Oh, okay, so yeah. So I'm just casting it to reflect as an integer, so I can kind of just hold it in integer variables.
Right, so when you teach time t0, that's a very large number because it's all the seconds since January 1st, 1970. And so casting it as an int basically shrinks that down to fit in size.
Yeah, because I don't remember, you probably know the number off the top of your head, but integers go from like negative 216.
No, it's minus, yeah, it's like minus 2 billion. Well, it's 4 billion and change if it's
Oh.
unsigned, so it's probably minus 2 billion.
Okay, nice. Yeah. So it just kind of shrinks it down into that. So that's good. And then the time, the whole point of that, and the reason why we're putting in the SRAM is because we're setting our seed. I mentioned this a little bit last week, or earlier this week, last week, I don't know. And so when it takes those seconds, it's setting it to the seed. So at any particular second that I run the code, it's giving it kind of a new seed. Because remember, random numbers are pseudo, they're not real. So it makes it a little bit more robust that way. Does that make sense?
Yeah.
Okay. Stones in the pile. Oh yeah. So we're still in our while statement here. Now I want to check win. So once again, this is really cool. I can call my check win, and check win is something. Where's it at? Check win is a Boolean, right? So it returns either a true or false. So when I do check win here, what's the condition I'm checking? The stones, it's going to return a true or a false. So if it's true, I can say you win. And then I'll break. Okay, that's the player's turn essentially. The computer's turn is pretty much the same code. So I'm going to just copy and paste it and just talk through it. So I'm another variable called computer move, setting it equal to this variable or to this function call. I'm telling the user how many stones they're taking. I'm subtracting it from the overall pile, and then I'm doing that check win again and then breaking. So now we should be able to actually run our what? Oh, because I'm already in. Wait, what?
Should that, did you compile it?
Probably didn't. Getting ahead of myself here. Beautiful. So I'm gonna take 5 stones. Oh, I can't. I'm gonna take 0 stones. Oh, I can't. Okay, I'll take 3. Peter takes 1. I'll take 2. I'll take 3. I'll take 1. Cool. Any questions on that?
We talked about this, I think, briefly, the const keyword.
Oh, const, yeah.
There are lots of times in here that it's very useful.
Yeah, give me one example of where you would put const.
So const would be, when you pass, go to check win.
Oh, check win. Okay.
So when you pass in the stones, if you do const int stones, right? If you don't, do const int
Oh.
stones,
Yep.
because basically you don't want stones changing
Yep.
while you're doing the work.
So you guys remember, it's just an extra parameter check, or it's an extra like security thing to help with bugs. So you guys remember in the first or second week with pi, you guys set it to const 3.14, and the reason why is because pi should never change its value. So it's the same thing here. In this particular scenario, we don't want stones to change. We're just checking true or false. So by making it a const here, you're making it more firm. So if there ever was a bug where we accidentally were taking away from stones or adding to stones, it would throw an error rather than introducing a bug into the code. So that's good, Michael. Thank you. Start thinking about how you can introduce this stuff, especially as we start getting into object-oriented programming. There's a lot of ways, a lot of times you want to introduce this, especially in like in your constructors and things like that. So.
And you can also have them on your output variables, so like, you could say const bool, right? So,
Yeah, yeah.
so there's other places you use const, but those are the 2 common places.
Yeah, so the difference between these two things here is this is setting the parameter variable constant. This is actually setting the return of the function constant. And you'll notice with pointers and everything else, usually what you can do in here with the variables, you can do out here with the return types. And it just gives it a slightly different interpretation. So I think it's bool const or something.
No,
I don't know why it was.
it's probably because const bool and then the highlight will tell you.
Cannot overload function distinguished by return type alone. Oh, that's interesting. Okay. Well,
So anyway, there's
cool.